In this video, I'm going to go over the review questions from our third and final review. And this was only over one section on 5.6. Now, this is when I was out of town. So if you're still having trouble with this, make sure, take your time, come in and talk to me about this. Maybe in office hours, we can do some of these questions from that 5.6 Delta Math link. All right, so I'm going to do 3 of these where I'm going to find all these different characteristics of these rational functions. I'm going to find the asymptotes, the intercepts, and see if there are any holes in these functions. So the first thing I'm going to do is look to see if I can factor anything in the top or the bottom. And I can factor out a -2. And when I divide those terms by -2, I get x minus 3. And then in the bottom, this is a quadratic trinomial. So I'm trying to think of factors of 3 that add to -4. So I'm going to have -3 and -1. Okay? Now, what I notice when I do that is I have a common factor that's the same in the top and the bottom. So I can cross out x minus 3 in the top and the bottom, which means I have a hole at whatever would make that equal to 0. So in this case, x minus 3 is equal to 0. So, or x equals 3. All right, so my hole is going to be 3 comma something. Now to find that something, I'm going to write down what's remaining. So what's remaining in my function is a -2 on top and an x minus 1 in the bottom. So to find the y value for my hole, I'm going to plug in the x value where my hole is occurring at +3. So if I do that, plug in 3 where it says x, I get -2 over 2, which when you reduce that, you get a y value of -1. So that's how you find the hole if there is one, right? If you don't cross out any common factors in the top and the bottom, then you just don't have a hole. Now, to find the vertical asymptote, all right, I always look at whatever is left in the denominator. So in the denominator, I see x minus 1. So what would make x minus 1 become 0? That'd be x equals a +1. For the horizontal asymptote, this is where you want to, actually probably easiest to go back to the original function. So if I look at the original degrees in the top and the bottom, the highest exponent in the top is a 1. The highest exponent in the denominator is a 2. When the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is y equals 0. Okay? For x-intercepts, this would be where I set my numerator equal to 0. So here's my numerator of -2. There's no variable with that -2 anymore. So there's no way for me to make the numerator anything other than -2. So because I can't make the numerator become 0 or set it equal to 0, I am going to write that there are none for x-intercepts. For the y-intercept, the work I'm going to do is plug in 0 where it says x in my remaining function. So -2 over 0 minus 1, which is -2 over -1, which is a +2. So my y-intercept is 0, 2. So that's it for the first one. I found all 5 things. I found my asymptotes, my intercepts, and then my hole. Let's do a second one. Same thing, see if you can factor out anything. I can't do anything in the top, but I can factor out something in the bottom. If I factor out the 3, I get x plus 5. Now, different than what we had in the first one, I'm not able to cross anything out, so this would tell me that I have no hole. Okay? So I'm going to go straight to my asymptotes. Remember, my vertical asymptote is whatever makes my denominator become 0. So if I look at my denominator, it says x plus 5. If I wanted to make that become 0, I would plug in -5 for 0. Okay, so that's my vertical asymptote. Horizontal asymptote, again, you can go back to the original if you want. The degrees are both the same, both x to the first power. So when the degrees are the same, your horizontal asymptote is y equals the leading coefficient over the leading coefficient. So this 2 over 3, or 2/3, is my horizontal asymptote. For x-intercepts, I'm going to set my numerator equal to 0. So 2x minus 3 equals 0. Move over the minus 3 with addition. Divide by 2, and you get x equals 3/2. So my x-intercept is 3/2, comma 0. If you want to use decimals, you can, right? You can write 1.5 for that. For the y-intercept, I'm going to plug in 0 where it says x. So 2 times 0 minus 3 over 3 times 0 plus 5. If you plugged it into the original, that's fine as well. So 0 minus 3 is negative 3. And then 0 plus 5 is 5. 5 times 3 is 15. If you reduce that, you get negative 1/5. So my y-intercept is 0, negative 1/5. Again, decimals are fine. If you're at negative 0.2 for the y-intercept, that's fine as well. So those are the asymptotes, the intercepts, and we did not have a hole in number 2. Okay, last one. Again, try to factor. I can factor out an x in the numerator, and I'm left with x minus 2 over x minus 2. This time I'm going to have a common factor to cross out. So I'm going to cross out, and it means I have a hole at whatever makes x minus 2 equals 0. So, or x equals positive 2. All right, so my whole ordered pair is going to be 2, comma, and then to find what is my y value for my hole, I'm going to write what's remaining. And what's remaining after you cross out the x minus 2 in the top and the bottom is just x. So if I plug in 2 to this function, I just get 2 for my y value. So my hole is going to be 2, comma 2. Let's talk about any vertical asymptotes. All right, so again, vertical asymptotes is whatever makes the denominator 0, but you'll notice that I ended up crossing out everything in the denominator, right? There's no denominator in my remaining function, so I have none for vertical asymptotes. For horizontal asymptotes, if you go back to the original, the degree in the top is 2, the degree in the bottom is a positive 1. When the degree of the numerator is greater than the degree of the denominator, you do not have a horizontal asymptote. So you write none as well. For x-intercepts, I'm going to set the numerator equal to 0. And when you do that, you actually get your x-intercept. It is 0, comma 0, right? Because 0 equals 0. You can probably imagine what the y-intercept is going to be. I'm going to plug in 0 into what's remaining, right? And when I plug in 0 into what's remaining, I get f of 0 equals 0. So if the x-intercept is 0, 0, or the origin, then the y-intercept is also the origin. All right, so that's it for all these questions. Again, if you're having issues with it, don't forget to go to the Delta Math link for this, 5.6, so you can practice some questions. Good luck on the quiz and test.